Good day, everyone. Welcome to our programming basics. The objectives of this lecture are the following. At the end of this self-study activity, the learner is expected to first familiarize the integrated development environment or IDE for R programming. We'll try to understand the basics in R programming using RStudio and practice commands in R programming using RStudio. Design and analyze the case study using R programming. I would like to encourage everyone to at least open your RStudio IDE while we are uh, into this lecture. Okay, so what is R programming? R programming, according to W3 School, is a popular programming language used for statistical computing and graphical presentation. It's most commonly used to analyze and actually visualize data. For some data scientists, especially those who are starting to learn about the science of data, right? They use an open source programming such as R programming to practice and become experts in data analysis utilizing algorithms and other techniques, higher techniques for statistical computing and applicable for data science. So why do we need to use R? It is actually a great resource for data analysis, for data visualization, for data science and machine learning. So as you will notice, as we are going to unfold the use of R in this series, and we are in the first lecture, we will be able to understand and at least practice now the use of data analysis, basic statistics via data analysis. We will do also data visualization, data science, and machine learning. We will be using some advanced algorithms uh, for machine learning from supervised to unsupervised machine learning. It also provides many statistical techniques such as statistical tests, classifications, clustering, and data reduction. It is easy to draw graphs in R. It's very easy for you to create graphs such as scatter plots, bar plots, histograms, pie charts, and a lot more in just a single line of codes and some a little bit tweaks, of the source code or the commands in R. So it also works on different platforms. You can do that. You can use R in Windows, in Mac operating system, more so in Linux. R, as I was saying a while ago, is an open source and a free software. There are so many communities or large communities that supports R. If you have questions about how commands are used, how this the interpretations of the output or outcome of your source code. For example, if you are utilizing in advanced machine learning algorithms, there are so many communities online that you can ask or you can do research about all of this. It has many packages, libraries, or functions that can be used to solve different problems. Now, from from basic statistics to advanced machine learning algorithms that, that are utilized for data science. So how do we install R? I would like to inform everyone that for you to be able to use the RStudio with R, you have first to install the core R programming language, where you can actually download it from this website, from the rproject.org, and click the link download R, and from there you are going to choose the version of the core R programming language that you think um, applicable or compatible with your operating system, whether you're using Windows, Mac OS, or Linux. And from there, you have to follow. After you download, you are going to just follow the instructions on how to install the choosing R versions. Okay, So after installing the core R programming language in your computer, the next thing to install is your RStudio. Okay, you can download the RStudio software or IDE from this website, posits.co/download, and then you choose your desired RStudio version. There are, as of the moment, there are two types. We have here the RStudio Desktop, and for the professional, we have the RStudio Desktop Pro with a fee. In my case, I am just using the free version of our Studio Desktop. Anyway, um, what I'm going to the purpose of using the free version is that uh, for a new uh, uh, becoming data scientist, or actually there are a lot of free or downloadable libraries that can be used for data science applications, and at the same time for for machine learning algorithms also. Even basic physics are already there, so it's just fine to use the free version. But if you want to go beyond on what you are doing in the free versions, I am recommending also to use the professional versions. There's also a server version of R and R Studio, which you can actually buy or subscribe from. All right. When you click the download button of the free version, you will see instructions on how you are going to install. Since we already done with the downloading and installations of your core R programming, you just skip to number 2 steps and try to download and install the RStudio. Just follow the instructions. And when you click that, you are going to choose the type of operating system in your computer that you think is compatible. Just choose the one that's compatible to your operating system, whether you're using Windows, Mac operating system, or Linux versions. So there are actually versions there of Linux that you can use actually. So whatever is compatible with your computer, just download it there. All right. So when we install the R programming, when you run it, we have this environment that we will see, the RGUI. Right. So we have three main parts here. I name it the top. I may name it as the toolbar where the menus are there, such as file, edit, view, misc, packages, windows, and help. And below that we have the standard toolbar with some icons there that you can use when you are using your RGUI. And below that will be your R console, where you are going to put your commands in the console, right? And then if we are using the RStudio IDE, we have the following parts. We have the toolbar, the standard toolbar, the source pane, the R console. On the right side, we have the environment pane. Below are the plot, packages, and help pane. Let's go through one by one. Okay, so what's the interface of RStudio? We have, of course, the opening RStudio will actually open when you open your RStudio, it will automatically launch the R software or R core programming language that you have installed previously. So roughly, let's try to describe the parts of your RStudio environment. We have here the left area. It includes the console. See at the bottom, we have here the terminal and the background tabs. In the top right area, we have includes the tabs environment, the history, connections, and tutorials. And in the bottom right, we have includes the file tabs, plots, packages, help viewer, and the presentations. On the upper left, we have there the of course the toolbar, the standard toolbars, and the source pane. Okay, so what's the console? Actually, on this tab, we first see the information about the R versions. For the first time that we use it of the RStudio, it will uh, show you the R version and also some basic commands to try. So at the end of those descriptions, we can type our R code by typing it there, then press enter and get the results below the code line. Okay, so let's say for example, if you'd like to try running the 2 times 2, and at the bottom will give you the result automatically. So virtually we can do here anything we would do in any other R programming. Say, for example, you can do installing and loading packages. You can do that in R console, performing simple or complex mathematical operations. Okay, assigning the results of an operations to a variable. We can do also importing data in the R console. We can also do some creating common types of R objects like vectors, matrices, or data frames, and among others. We can do also exploring the data in the R console, right? Statistical analysis. We can do building data visualizations. And for the environment, excuse me, whenever we define a new or reassign an existing variable in RStudio, it's actually stored as an object in the workspace and get displayed. Together with its value, its value on the environment tab is actually on the top right of your RStudio area window. So try to running in the console. Um, with a variable name greetings and then less than dash, then in close with a double quotation hello world in the console, and try to see what happened in the environment tab. Okay, just try that. Now, this also relates to more complex objects such as data frames. You can do that also in the environment. In the environment, it is automatically being displayed there. Anything that you do in the console or even in the source pane, when you run it, automatically there is an effect in the environment. In other words, the environment basically show you the history and the things that is going on in your source code. Okay, in this example, for example, here we have the greetings hello world. As you can see in this slide, by looking into the environment, you will notice that there is a table there, the values, where greetings will show you also that the greeting value has a value hello comma world in exclamation point. Also with the vector, my vector will also show you that the things in the console is treated as enum or integer with four values from 1 to 4. Okay. Actually, we can change the way of displaying our variables with the list to grid in the top right corner of the tab as shown in the environment. Okay, so other important tabs that you can observe in the RStudio are the following. We have the terminal history files plot packages, which is found at the bottom left corner. So when we say terminal, it is to run commands from the terminal. And for the history, to track the history of all operations performed during the current RStudio sessions, which is actually found in beside the environment tab at the upper right corner. The files, okay, to see the structure of the working folders, you can preset the working folder, navigate between folders, and among others. You can find it at the bottom right corner, just beside plots files. That's right. We have beside that we have the plots to preview and export created data visualizations, and then packages to check what packages were loaded and load or unload packages. Okay, by switching on and off the box to the left of a package name is by loading or unloading the package. All right, so how do we install packages in RStudio? So we have here the syntax as install the packages, then open and close parentheses, enclose with the double quotation, then you write there the package. For example, here the install the packages, the tidyverse, as you can observe here in the red colored mark. That's how you're going to do that. But you can also install, if you do not know actually the name of the package, you can actually install a package by clicking the tools or by clicking the install button on the upper left corner of the packages found at the bottom, right upper I mean lower bot right button over there. So you can see that. Just click that one, then the type the name of the package. There is actually a message box there or dialog box where you want to put the your desired library that you wish to install. Just type it there, then click install. And then how do we load our packages? It's after you install the packages, you can now it is now ready for you to use, but you have to call that, okay, by typing the command in the source pane or in the console by typing library open and close parenthesis the package name. For example, since we installed the tidyverse, you just write in the console or in the source pane library tidyverse. You close the tidyverse with a parenthesis. So, meaning you have to load all the necessary packages in a script file rather than in the console. It's much easier because the next time around that you need to run the program, all you got to do is to just access the script file, the R script. Same thing with loading and unloading installed or system packages can be done by searching and unticking those packages on the packages tab at the lower right corner. Note that some packages can't be unloaded if they were important or imported by other packages. Okay, so how do we check loaded R packages? Just run the console, then do the command dot packages, open and close parentheses, or just click search, open and close parentheses to get the list of all loaded packages in your file or in your script. So in RStudio, open the packages tab, search for a specific package, and check if the box to the left of its name is actually ticked. That's one way also of checking if what are those packages or R packages that are actually loaded or in use in your script. So how do we get help on an R package or any built-in R object? So to get help on uninstalled and loaded packages or a function of uninstalled and loaded packages or any other built-in R objects such as preloaded dataset, use one of the following syntaxes such as syntax we have here, the help package or function name or help, open and close parentheses, the name of the package, or just simply write the question mark in the name of the package. For example, we have here help read.csv or question mark reader r read r or help open and close help, or you want to know the dataset CO2 uses help CO2 or question mark CO2. That's how you get help, and you will notice in the lower right corner under the help tab, it will show you the informations about that information that you need to know, the description. All right, so for now I would like you to download the world population from Kaggle. Here you can click the world population link from Kaggle and zip it into the same folder where you store your R script, so that we'll be able to do some activities about the world population datasets. So the results of running the above piece of code will be in an R data frame in your working folder as a CSV file. So importing, so take note that we have, for example, assuming we have downloaded the world population. So take note that you can do that by file import datasets or just click import datasets on the environment tab. Just locate where your CSV file or XLS file are saved, and automatically it will show you this sample here since it is a CSV file, or it will just give you actually the table itself, whether it is a text base or either it is a CSV file or an XLS file. It will show you actually a table such as like this in the importing data, the import dataset dialog box there. So after that you can click import. Right, so when you click import in the environment tab, you will see there the effect of that importations. Just double click the word population in the environment, and then it will show you at the left side, somewhere in the somewhere in the source pane, the table of the world population. What do you call this data frame? So I want you to try that and try to navigate this how you import and download, importing, and so on and so forth in this activity. That's one of your activity. All right. So accessing built-in R data, just do see the full list of available sample datasets preloaded in R, just including their names and short descriptions. Just run in the R console or in the source pane the this command data open and close parentheses. Then hit enter or run, and it will show you the list of sample datasets that is actually present or preloaded in your R core R programming language. You can actually take any of the appeared names and use each of them as a variable, so containing a data frame to work with and practice your skills in R. So if you need more information about the selected preloaded datasets, just run help function on it. An example here, we have help CO2. All right, so since we're talking about CO2 or carbon dioxide emissions and among others, so just hit it. Just try to use that in your RStudio by following these commands here. Then tell me what had happened by demonstration in the next meeting. Uh, what happened to these commands here when we run, such as the head, tail, call names, dim, str, summary of CO2, summary of CO2 uptake variable, then the median of CO2 uptake variable, the class CO2 uptake variable, the unique CO2 treatment variable, then the subset of CO2 conc equals mean CO2 conc variable. Right? So just your assignment. So, how do we plot data in RStudio? For example, if you in RStudio, as I was saying, you've discussed that you can actually do some plots by or visualizations through RStudio. So we can, as let me recall, what you can do. You can do some pie chart, bar chart, histogram, scatter plot, and among others. Okay, so assuming we are just using the CO2 database and orange built-in datasets, in both cases, the resulting plot appears on the plots tabs and can be exported using the export button of that particular tab. For example, if you would like to create a histogram about a particular variable under CO2 datasets, for example here uptake, you just type the command hist, H-I-S-T, then open and close parentheses, the name of the dataset, a dollar symbol, then the variable uptake. So and then when you hit run, it will show you there the histogram of the uptake variable under CO2 dataset. Okay, so you can do also some plots, such as like this here. So how do you do a scatter plot? So just try to put the command plot, then open and close parentheses. For the x and y coordinates, for the x we have the CO2 dollar CUNC variable, and for the y we have here the CO2 uptake variable. So when you hit run, it will show you this output below. Now you can do some tweaks. If you want to put colors, for example, if you want to specify the x and the y axis, if you want to put a specific variable there, so you can do that here. So we have the x lab equals to conc, and then the y lab is equals to uptake with capital C and U respectively, and the name of the table, you can do that by using main equals carbon dioxide concentrations versus carbon dioxide uptake rates. And for the color, we use blue, and for the size, you can use 16. Okay. So creating data from scratch in R, so you can do also like a vector. So you assign that vector to a particular variable, such as here we have ocean. Okay, then less than dash, you assign. Okay, and you combine with the Arctic, Atlantic, Indian, Pacific, and Southern. So all of those here will be placed to oceans. Okay, same thing for the average depth. We have here an example. Okay, to create a data frame from oceans underscore depth, the data frame, the data that frame ocean, and the average depth is what you have in your in the previous example. So just to show the result, just print ocean depth and it will show you a data frame. So in conclusion, in this tutorial, we explored plenty of essential aspects of using RStudio, such as what RStudio is and what advantages it has, how to install RStudio. We have what the RStudio interface looks like, and how to use its main parts. So the difference between running code in the console and the script. We also where to find all the objects used in the current studio sessions, and then the best practices for writing script, how to perform various operations in RStudio, such as installing and loading our packages, importing data, wrangling, analyzing, and visualizing data, creating R objects from scratch, etc. So now you're familiar with the RStudio, you can go ahead and start using it. For example, think about building your own R projects in RStudio, or you can go back to the world population and try to practice the command that I would like you to use a while ago as presented. All right. So with this, thank you very much for your time and listening. And it's time to practice using your RStudio. So here are the references of these discussions. I would like to thank the W3 school websites where I get some of the informations, and most of it are from DataCamp. And also I'd like to acknowledge also Kaggle for the data sets that we will be using as to practice in using RStudio software, or the R programming language. Right? Thank you very much, and see you around.